Right, so we're going to have a look at through the non-calculator graph test that we just did. And we're going to start off with question 1. And we're given f of x equals minus x squared to start with. We should know what that looks like. Well, in fact, we do know what it looks like because it's given to us in the paper. And where are we? There we go. Right, okay, so it's a bit off the screen, but anyway, you can see what it looks like there, and you've got the same on your paper. And then what the question asks is, what happens to it? What's it look like if you change the formula from f of x equals minus x squared to f of x equals minus x squared plus 9? Now, this is the most sort of basic transformation that we do, and if you start off with a function, whatever it is, like 1 over x, or x squared, or minus x squared, or all the basic functions that we work with, if you add or take away something to the end, adding moves it up that many places, and taking away moves it down that many places. So if I had the graph of minus x squared plus 9, I'd expect it to move up 9 places. So let's flip back to our calculator, and we'll turn down and change that to plus 9. That, and it moves it up 9 places, and looks a bit like that. So we now know that this, because it was at 0, 0, now that this here has gone up 9 places, it's going to be at 0, 9, so we should know that intersect. We need to know these ones down here as well. But if you think about the graph that we had, if you think about what would happen to 3 before we put the 9 in, before we put the plus 9 in, before we put this in here, when we just had minus x squared, 3 squared would be 9, make it negative would be minus 9. So at 3 would be down to the point minus 9. If I move it up 9 places, then it's going to be 3, 0. 3 squared is 9, make it minus is minus 9, plus 9 is 0. So this is going to go through at 3, and likewise it's going to go through at minus 3. So we should have got the 3 points as being 3, minus 3, and 9 on the y-axis. Second part, B, was similar, and that was, let's have a look, f of x equals minus brackets x minus 2, all squared. So this is like the original function minus x squared, but instead of x now, I've changed it for x minus 2. So here I did have x, now I've got x minus 2. If you take a function and you change the x for x plus or minus something, it moves it left or right. The first one moves it up or down, the second one moves it left or right, if the thing you're adding on is inside the bracket. And it's a bit counterintuitive, because if you add something, it moves it left that number of places, and if you minus something, it moves it right that many places. So here, I've taken away 2, so I'd be expecting the whole thing to move to the right 2 places. So let's go back to our calculator, and we'll tab down again, and we'll change that to, not right. Let's have some brackets. Minus 2, close brackets. Okay, so we've got the original graph, and it's just moved to the right 2 places. Now again, you can think of, it was at 0, 0, so now it's going to be at 2, 0. If you think about what happened at 2 over here originally, 2 squared is 4, make it negative minus 4. So the point down here wasn't originally minus 2, minus 4. But when I move it across 2 places, it becomes 0, minus 4. So this point down here will be minus 4. And then the third one was, where are we? F of x equals minus 2x squared. 2x all squared. So again, we swapped the x for 2x. Like in the previous question, we swapped the x for x minus 2. We've now swapped the x for 2x, again inside the bracket. So what happens there is that, and I've just written it down here, if you swap the x for something times x, all the x coordinates, all the previous x coordinates get divided by that number, divided by 2. So what that looks like in practice, if I flip back to this, let's get back to my just the basic graph again. Oh no, that's not one. It's down here. Okay, so there. Now I've got my point, 0, 0, and then 1, -1, 2, -4, 3, -9, and so on. Now when I change it to in brackets 2 lots of x all squared, you can see the graph gets skinnier. Now what's happening there is that instead of going through the point 2 -4, which is what it was doing, the x coordinate gets halved. So instead of being 2 -4, it's now 1 -4. Instead of it being 3 -9, it's now going to be 1.5 -9. So if you can work out the coordinates of some of these points, then halve the x coordinates, and you get this new skinny graph. Okay, so 4 would have been -16, now it's going to be 2 -16, and so on. This point here stays exactly where it is because half of 0 is 0, so it doesn't move. Okay, so that was the first three. State which functions are even. Okay, we've got some space down here, so let's have a look at... now, an even function will be symmetrical about the y-axis. So, for example, something like this, where it's symmetrical about the x-axis, the y-axis would be an even function, or that is symmetrical about the y-axis. If one side is a reflection of the other side, then it's an even function. If it's a vertical reflection, if you could fold it across this way, and one side folded onto the other side, then it's an even function. So in our case, the two even functions are the first one, a, and the third one, c. The second one wouldn't be, because the second one looks more like this, coming across here like that to here. Now, if you folded this side across, it wouldn't match. There's nothing over here for it to fold onto, so that's not an even function. Okay. So that's question 1. Part 2, and then state the values where it's increasing. Well, let's go back to our graph again, and we'll change it back to the one it's talking about, which is x minus 2. Okay. Where is it increasing? Well, if you imagine walking across, okay, from left to right, the way you read, you come across this way, and you get to here, you get to the graph. If this was like a hill, you had to climb up this hill. You'd have to climb up to the top, and then you got to the top, you'd slide down again on the other side. Okay, so walking left to right, you'd have to climb up here and slide down the other side. So when you have to climb up, it's increasing. The function's going up, it's increasing. And then when you can slide down, it's decreasing. So here, you'd say that the function is increasing. I'm running out of space a bit. Should we squeeze it in the bottom? Down here somewhere. It's going to be increasing as long as x is less than 2, because when it gets to 2, it starts going back down again. So it's increasing when x is less than 2. Okay, that's that. Right, I'll stop this one. That's all question 1, and I'll do a new one for question 2.